Assalamu alaikum. In kinematics, equations of motion plays a very important role. It relates parameters such as displacement, velocity, time and acceleration. In this way, we will drive equations of motion with the help of calculus method. Let's do it. To drive equations of motion, I consider an object moving in a straight line. With the uniform acceleration E. When we say uniform acceleration, before I tell you about the uniform acceleration, we must know what is acceleration. Suppose if there is an object changes its position with time, then it is considered to be in motion. Any moving object, if changes its position with time, means it possesses a velocity. So velocity is nothing but change in displacement of the object in a given time. Rate of change of a displacement is referred as velocity. When this velocity changes with the time, then we can call it as acceleration. So acceleration is nothing but rate of change of velocity. How do we represent this mathematically? Using equation, we represent acceleration as dv upon dt. This is a first order derivative of velocity with respect to time. This acceleration, I hope you have understood. Whenever velocity of a moving object changes with time, then we say that the object is under acceleration. If this variation in velocity remains constant throughout the motion of the object, then we call such acceleration as uniform acceleration. It means velocity is increasing in equal rate. Clear? Let's go ahead. So when the object is moving with uniform acceleration at a time t, or you can say when a time is 0, the velocity is taken as u, it's the initial velocity. Okay, when time is taken to be equal to t, velocity, this is a final velocity, is represented by term v. So here u is initial velocity and v is the final velocity. Got it? Now we'll go ahead. I'll start with this equation of acceleration. So a equals to dv upon dt. So here I'm going to get the relation between velocity and time. So velocity, time relation, or VT relation in simple word. Okay. In order to remember this in an easy way, suppose if you want to drive the relation between velocity and time, what do you need to do? Take a change in velocity and divide it by change in time. You get the acceleration. Okay, with this we start. Alright. Okay, now before going ahead, there are certain things I do want to explain you here in this equation. I told you acceleration is nothing but rate of change of velocity. What is acceleration? rate of change of velocity. What is this rate of change of velocity? This change in velocity is represented by letter dv. Here d stands for change, and it is the symbol of a differentiation, change in velocity. Now here I have rate, the term rate. Whenever we divide a quantity with a time, then we obtain a rate of that quantity. Remember that. So here rate of change of velocity means dividing dv with a dt. Now when some phenomena occur, with the occurrence of that phenomena, time will also change. It is not going to remain same. Earlier it was 0. With the occurrence of phenomena, the time might have changed to some value, maybe taken as t. Okay, so change in velocity with the time is referred as the rate of change of velocity. Got it? That we call as acceleration. Now I'm going to make certain changes to this equation. What I'll do, I'm going to take dt, which is present in denominator, to the left hand side of this equation. If I do so, the term which is dividing or taking to the another side will multiply with the term present here. So we'll get this. dt will multiply with a. You get an equation is a dt equal to dv. Now I take this equation, I rearrange it. Rearrange this equation. So if I write it as dv equals to a dt. Okay, that's how I rearranged it. Taken the term present in right hand side to the left hand side, and the term present in left hand side to the right hand side. Okay, so that's not going to make any difference here by doing so. Then see, very important thing that I'm going to do here, I'm going to integrate this equation. What is this integration? Already I have used the term differentiation. This differentiation and integration are part of calculus. Now this you will learn in mathematics in detail. If possible, I will make a separate video on calculus. Now it has got two parts, integral calculus and differential calculus, which was introduced by the father of physics, was nothing but Sir Isaac Newton, to make the calculation of certain things easy. So in different branches of physics, we use calculus to make our work easy, to make the calculation easy. It is used. Okay. Now I will not go in detail. There are certain formula used in this topic relevant to differentiation and integration. That alone I will cover here. Okay, so that it becomes easy for you people. Now I am going to integrate this equation. So I take it as equation number 1. Integrating equation number 1. Integrating equation 1. See, if I integrate, what happens? Put it carefully. Here, integration is represented. See, this is the symbol of integration. This is actually an elongated S. Elongated S. Elongated S. It represents integration. This represents a integration. Integration. Clear? So why S is used as a symbol for integration? Here this S stands for summation. It is a kind of a summation process. Okay, and differentiation is just opposite to integration. It's the opposite of integration, and it is represented letter D. Clear? Let's go ahead. Now I take this term dv equals to, and at this side also I am going to integrate. So integral of a dt. Now see next what I do. You remember we do not integrate a constant term. Which one is constant term here? Here see, velocity changes from u to v. Here time also vary from 0 to t. So these two are variables. The only constant here is nothing but a. I told you a is a uniform acceleration. It means that it is a constant. Let me mention it here. A is a constant. When I say acceleration is uniform quantity, it means it remains same throughout the motion of the object. Alright. So we do not integrate a constant, so it has to be taken out. And now before doing so, I told you earlier, the velocity varies between u and v. So initial velocity is u. This is the lowest value of or least value of velocity. So it is mentioned at the bottom. So we call this one as lower value, and the upper value, which is v, final velocity, is mentioned at the top. Alright. Then in a similar way, here this side the variable is time. So need to mention the lowest and the highest value of a time. The lowest value is 0. That I mentioned here. Lower value. The upper value is nothing but t. Clear? So lower limit is called as upper limit in the integration. Clear? And here a is a constant. We do not integrate a constant. That is why what we do, it is taken outside. So this equation can be rewritten as integral of dv with the lower limit u and upper limit of v equals to, a is written outside, it's taken outside, and this term, integral of dt with the lower limit 0 and upper limit is t here. Clear? Let's go ahead now. We'll see what I am going to do. It's a very important thing that you need to remember. One formula I am going to mention here relevant to integration. See, integral of dx. Suppose you integrate a term dx. If you integrate dx, this d will disappear because d stands for differentiation and this integral stands for integration. These two are opposite functions, so they cancel each other. They cancel each other, and what remains here nothing but yes. Got it? Now that thing I am going to apply here. If we have limits, then how it has to be done? But I'll show you here. Now if you come across the integral term without limits, it means it is called as indefinite integral. If we have a limit, then it is called as definite integral. Okay? Let's see. Let me integrate this one. Now I integrate dv. If I integrate dx, I get x. In the similar way, if I integrate dv, I get v. I get a v. I write within bracket. Now outside the bracket, I write the limits. Lower limit u, upper limit is v. Equal to sign. Then here a is written as such. Then I integrate dt. If I integrate dt by following this method, this formula, I will get t. Then lower limit 0 and upper limit 0. After that, in the place of these variables, I am going to mention the lower limit and upper limit. Clear? Let's do it. Look here carefully how I do it. In the place of v, I write upper limit first, then minus the place of v, write a lower limit. Then equal to sine a. Then in the place of t I write upper limit. This is again t minus the place of t I write a lower limit, that is 0. Got it? So this is what we can. The same I am going to write here. The t minus 0 is what? T minus 0 is nothing but t. It is t. Got it? So v minus u equals to a multiplied with t. This is what I get. The next, the final equation I obtain is v. I take u that side. Here we have minus u. When it is taken to the other side, it will get added to the term present here. So v becomes equal to u plus at. Now let me box this. This is the final equation. This is called as first equation of motion. This is called as first equation of motion or first kinematic equation of motion. Okay. Take it as equation number 1. We got the first equation of motion. Now I'll derive second equation of motion and the third equation of motion. Got it? Here, before going ahead, let me tell you why we call this one as velocity time relation. This equation represents the relation between velocity and time. You can see here we have v. It stands for final velocity, u stands for initial velocity, and here t stands for time. So this gives the relation between v and t. Also we have a here. Okay, this is called as velocity time relation. Now I'll get the relation between displacement and the time. Displacement time relation. Displacement time relation. We know displacement is represented letter S. Displacement is represented letter S. This is the symbol of a displacement. Okay. Now, say I'll take this equation. Good here. To find the relation between these two, take a change in displacement, that is ds, and divide it by change in time, that is dt. ds by dt, change in displacement with time, referred as rate of change of displacement. Rate of change of displacement. That means change in displacement with the time. Rate of change of displacement is nothing but velocity. What is that? Velocity. Similarly, rate of change in velocity. Rate of change of velocity is acceleration. Correct? Now I cross multiply this by following the same method. Now I am going to take dt with the another side, the left hand side. If I do so, it will multiply with v. So v multiplied with the dt. On doing so, what we get is ds remains as such on the other side. Okay, then I rearrange it. That's ds equals to v dt. By doing so, the value is not going to change. Clear? Then I am going to integrate this equation. Integrating the above equation. Now before integrating this one, here let's find out which terms are variable here. here displacement and the time are a variable because d has come in front of them. Okay, here when the time is a 0, the time displacement covered by the moving object is also 0. When time has become t, that moment displacement becomes s. That I write here. When time is 0, displacement is 0 meter. Okay, time is measured in second, 0 second. When time has turned into 0 t, so t is considered as maximum value. Okay, then displacement is taken as yes, the final value of or highest value of yes in our case. Now with these values, I am going to integrate this equation. Okay, let's do it. I'm going to integrate this equation. Integral of ds equals to integral of v dt. Now I'm going to include the limit, lower limit here is 0 and upper limit is yes. The similar way, the lower limit for time is 0 and upper limit is t. Now I told you we cannot integrate a constant. Here, in this case, v is a constant. So it is a okay. Before doing so, I'll do one thing. We know the value of v. I'm going to substitute the value of v in this equation. So I will name this as equation number 2. Substituting equation number 1. Substituting 1, equation number 1 in 2. What I will get if I do so? In the place of v, I am going to write u plus at. Integral of ds, lower limit 0 and upper limit yes. Okay, and here integral of v dt. In the place of v, I write its value. There is nothing but u plus at, then dt from here as such. This is what we get. Now the next step, I am going to expand this part. I'll take this term as such. Then I'll expand this. To expand this will get multiplied with this, and this also will multiply with this. Okay, and we'll do it separately because plus is present at the center between them. U dt plus a t dt. I take this within a bracket just to show you that we are going to integrate the whole term. Clear? Now again I will expand this. Let's see, integral of ds with the lower and upper limit as 0 and yes, and this side I expand. Now this integration will go with each part of this equation. 0 to t u dt plus integral of at dt. Then here limits. Clear? Now in these two parts of this equation, here u is a constant, so it will be taken out. Here a is a constant, so it will be taken out. Okay, if we do so, use of different color. Yes, ds here is taken out. Integral of dt with the limits as 0 and t plus a integral of t dt. See here I haven't taken out this t outside because it is not a constant, it is a variable. Okay. Now I am going to introduce one more equation here, which will be helpful to integrate this term. Okay, what is that? I'll tell you. Now I will integrate this part first. When I integrate ds, it will become s. When integrating this one, it will become s. Now I take this within a bracket and I write the limits outside. U is kept as such. I am going to integrate this. On integrating, it will become t, 0 to t plus a is written as such. Now I am going to integrate this term, that is d dt. Look at here carefully what I get on integrating this. When I integrated dx, I obtain x. If I integrate, I introduce one more formula here. Integral of x ds. This equation is similar to this one. Okay. If we integrate x dx, then we will get x square upon 2, which can be written as half x square. Okay, in similar way, I write as well as half x is, I'm sorry, not x. Here we have t. Half t square. Got it? Is what we get. Then we have the lower and upper limit. Right? Now I'm going to substitute the upper and lower values. This upper value is lower limit 0. Here the same upper limit t minus lower limit is 0 plus here a. I take out a half outside. Now I skip one step here. This half is taken out. Half a. In the place of t square, I mentioned the values given in upper and lower limit. The upper limit is t, is measured as such as t square, and a lower value is 0. So 0 square is 0. It is mentioned as such. Okay. Now I am going to simplify this equation and see what we get if we do so. S minus 0 is nothing but s, and the t minus 0 is t. So we get ut plus half a, and here we have t square. This is the second equation of motion. I'll box this equation. Right? This is the second equation of motion. I name this equation as equation number 3. Now we will drive third equation of motion. Before doing so, let me provide you some information about this second equation of motion. Here, we call this one as an equation which relates displacement and time. Why is it so? The reason is, if you look at here carefully, this equation gives us displacement, and displacement here is related with time. We got time. The term time is present here twice. So it is simply called as time and displacement relation. Okay. Now third equation of motion is referred as velocity time velocity and displacement relation. Velocity displacement relation. Okay. To get the relationship between velocity and displacement, I start with this equation. E equals to dv upon dt. Now, this is the equation of acceleration, rate of change of velocity. This is the first order derivative of velocity with respect to time. That is nothing but acceleration. Now this I have told you earlier. Okay. Now I'm going to make certain changes to this equation. Now what I do, I multiply this equation with the ds. Then I'll divide it by ds. If I do so, then when ds is divided by ds, I get 1. Now when something is multiplied with 1, it is not going to make any difference. The value remains as such. So, the value doesn't change. Clear? Then after that, I'll do certain modification to this. See what I do? Yeah. Write it this way. Plus ds upon dt, ds divided by dt, and this ds will go to this end. dv divided by ds. Now what I have done? Just I brought this one here and it is taken to that side. Now we know very well in a dot product, a dot b equals to b dot a. Now both are same. The same thing I have done here. Okay. So it has not making any difference here. The next, we know very well rate of change of displacement is nothing but velocity. So this term becomes v. No? The rate of change of displacement is velocity. ds by dt is v. So in the place of ds upon dt, I write v. So this equation turns into this. E equals to v dv upon dt. Now I'm going to integrate this equation on integrating the above equation. What I do if I integrate this? See, now before integrating this, I make certain changes to this equation. The dt is taken that side. A dt, it will multiply on taking it to the other side, and what is remained here is nothing but v dv. Okay. Now I will integrate this equation by following the same method that we did earlier. Now I skip one step here. I keep the constant outside. I integrate this term alone. And here initial value 0 and the final value is t. Here initial value is u, final value is v. vd v. I told you integral of x dx is x square upon 2. The same formula I am going to use here. Next step, see what I will get. A bracket on integration will become t, lower limit t 0 and upper limit is t. Then here on integrating this one we get half v square, lower limit u, upper limit v. Now I am going to substitute the limits. Here a, in the place of t I will put the value of upper limit, that's t, minus in the place of t I will put the lower limit value. Okay, and here half is taken out. In place of v square I use the upper limit value, then minus in the place of v I write the lower limit value, that is u. Fine, this is what I get. But t minus 0 is t. So on multiplying this two I get at. This side I have half v square minus u square. Now 2 is taken this side, it will multiply by doing so. What I get? 2at equals to v square minus u square. Now I rearrange it. I take a u square. If I do so, minus u square will become plus u square. U square plus 2at is equal to v square. Okay. Oh, yeah, see, I have done a small mistake here. What remains here is nothing but a ds. So I have to take a ds this side. It's not a dt, it is a ds. So here it is ds. It is not a dt. I made a small mistake here that I am rectifying now. The same here. So if it is yes, here I have yes only. It is not a t. Extremely sorry for this one. Yes, here it is also the limit is a yes. Fine. So what I get here is nothing but yes. So it is so a gets multiplied with the yes. This is what I am thinking. Why I get a t here? We should get a yes. Right? Now I rectified this formula. So it is not a t, it is a yes here. Right? Fine. So I rearrange this formula. It does. So v square is equal to u square plus 2a. Yes. This is the final expression which gives us third equation of motion. I name this as equation number 4. This is how. So these three are the equations of motion. They are otherwise known as kinematic equations of motion. Okay. We can also derive the expression for S in terms of u and v. Let me show you how it can be done. For this, I take a first equation of motion, which is nothing but v equals to u plus at. Then from this, I get the value of at. Now by taking this term to the other side. So what happens if I do so? I'll get v minus u equals to at. Now this is I take as equation number 5. Then I take the equation third equation of motion. The third equation of motion. Third equation of motion. So nothing but S equals to ut plus half at square. To this equation, I am going to make certain changes. I will modify it. What is that modification? What I make to this? See, yes, it's kept as such. Ut it's also kept as such. Half it also kept as such. Then see, I take a t outside. Half at multiplied with t. If you multiply this term, you will get half at square. So this is not going to change the value of this equation. Okay. Then here I name this equation as equation number 6. Now in the place of at, in the 6 I am going to substitute the value of 5. Now 5 is the substituting 6. Substituting equation 5 in 6. See what happens if I do so. Yes, ut plus half at is nothing but v minus u. V minus u t. Okay. Let's see. Now expand this expression. Yes, equals to ut plus half, and t is multiplied with each term present within the bracket. So half v multiplied with t minus half u t. Already we have t here. This ut minus half ut. We get half plus half ut. I'll use 2 more steps to make you understand this one in a better way. Ut. Here also we have ut. So just take a note, or I don't think I arrange it this manner. Ut minus half ut plus half vt. Alright. Now what is common here? Common term is ut. Common term is ut. Yes, sir. Take common term as ut. What remains is 1, and here half plus half vt. Understand? Now 1 minus half is nothing but, what I get if I do so? Plus half. What I get is plus half. Clear? So this is equal to half ut plus half vt. Now what is the common term here? Common term is half t. So the next step, I get this. Yes, equals to half t multiplied with u plus v, or this can be written as u plus v divided by 2 multiplied with the half. I'm sorry, multiplied with the t. Sorry. So this is the relation or new expression for s in terms of u and v. Clear? I name this equation as equation number 7. Right? I'll box this one for better visibility. Right? Now I will write all the equations of motion here one by one. Let's see whatever we have derived till now. The first equation of motion, called as equations of motion. equations of motion or kinematic equation. This first equation of motion is V is equal to U plus EAT. V is equal to U plus EAT. That's first equation of motion. Next, second equation of motion. And this is equal to UT plus half EAT square. And third equation of motion is this. V square is equal to U square plus 2AS. 2AS. Now, this equation, which represents displacement, can be written in this manner. So, I include this equation also here. S is equal to U plus V upon 2 multiplied with the T. Okay. So these are equations of motion, otherwise called as kinematic equation of motion or kinematic equation in simple. Now, before I come to the conclusion, before I conclude, I would like to tell you a very important thing about these equations. All these equations are valid only for a moving object in a straight line. Suppose if there is an object moving in a straight line with uniform acceleration, only for such object we can apply these equations. If the object is under circular motion or there is an object under oscillatory motion, in both the cases we cannot apply these equations. Got it? So these kinematic equations are valid only for an object under uniform linear motion. Clear? Before conclusion, let me tell you what is the circular motion. Already I have made a video on this. Suppose there is an object moving in a circular path, then we call it as circular motion. And there is an object. Let's take the example of a simple pendulum. If I disturb a simple pendulum, if I apply force on it, it moves towards one side, then it returns back to its original position, then it continues its motion in the opposite direction, then again it returns back. This kind of to and fro motion is referred as oscillatory motion. For circular motion and for oscillatory motion, these equations are not applicable. Remember this. I hope the video is useful. If you have any kind of doubt related to the topic, can you put a question in the comment section? Thanks for watching.